Hello students, we continue our revision of standard 11th indefinite integration. The first sum sin x upon 1 minus sin x dx. The first step I is equal to. So let us write that. Now what are we supposed to do in this particular sum? We have 1 minus sin x in the denominator. Let me just copy this step once again because I am going to add on to this step. Now whenever we have 1 plus minus sin x in the denominator, what are we supposed to do? We are supposed to multiply by conjugate. Very important point. You will require this throughout. If you have 1 plus minus sin x in the denominator, you can multiply divide by conjugate. Here the conjugate of the denominator will be 1 plus sin x. So I will multiply divide by 1 plus sin x. Okay. So in the next step what I am going to do? I am going to write the denominator as cos square. Now you will be wondering why cos square? Students, if you observe, what you have is 1 minus sin x into 1 plus sin x, which is 1 minus sin square. So in the next step, what will I find is sin x plus sin square upon cos square. Obviously dx has to follow. Now what do we observe? We have seen this in the earlier sums. Again I repeat, denominator is a single term. And whenever denominator is a single term, you will find a red line. That means separate the numerator. So we'll write in the next step as sum of two integrals. Integral sin x upon cos square x dx plus integral sin square x upon cos square x dx. Is that okay? Now let me just copy this to the next slide. So here is what I have in the integral. Now, how do we simplify sin x upon cos square? Let us do some rough work. So, sin x upon cos square can be written as sin x upon cos x into 1 upon cos x. Sin x upon cos x is tan x and 1 upon cos x is sec x. So, instead of sin x upon cos square in the integral, we will write tan x into sec x. So, that is what we write here. The second integral gives me tan square x. Now, you may be wondering, why are we not writing the answer to integral tan x sec x, wherein we know the answer? Tan square x needs to be simplified. And how do we simplify that? We have studied in the earlier module. Wherever tan square comes in this chapter, we replace by sec square x minus 1. So what we will write here is integral sec square x dx minus integral 1 dx. All the integrals are in the standard form, so we can in the next step write the respective formulas. You don't have to worry, I am giving you the formula here. Integral sec x tan x is sec x, integral sec square x is tan x, and integral 1 dx is x. Obviously a plus c, and that's your final answer. Let's take another question. Now this question in front of me, the very first step is copy the same question. So what we will get here is the question. Now I observe that denominator is a single term. Again and again we are seeing whenever denominator is a single term, what are we supposed to do? We are supposed to separate. Is that clear? Now when we separate, what do we get? We get e raised to x cos x upon 4 raised to x cos x dx minus of again integral 4 raised to x tan x upon 4 raised to x cos x dx. Cos x gets cancelled in the first integral. In the second integral, 4 raised to x gets cancelled. What is left in the first integral is e raised to x upon 4 raised to x. Can I say both of them have the same term in the exponent, that is x? So can we write it as integral of e by 4 the whole raised to x? Is that okay with everybody? Okay. Likewise, tan x upon cos x can be written as tan x into sec x. Is that okay? Let us see how to solve this. So I'll keep this here. Now e by 4 raised to x, is there any standard formula like that? Now e by 4 raised to x is not e raised to x. So then it has to be a raised to x. What is integral a raised to x? It is a raised to x upon log a. In this case, the value of a is e by 4. So what we will write here is e by 4 raised to x divided by log of e by 4. Minus, now integral sec x tan x is sec x plus c. Now students, we can simplify the denominator. It is log of e by 4 can be written as log e minus log 4, but you will surely add up to it saying that sir log e is 1. So can I write 1 minus log 4? Very well, see this. So you have e by 4 raised to x into 1 upon 1 minus log 4. Minus sec x will follow as it is, plus c has to follow. There is no further simplification. So this becomes your final answer. Let's see one more example in this particular module. I have an integral in front of me. How do I solve? Let's first copy the question. So here is the question in front of us. What do we do in this particular sum? If you see, the numerator and denominator both are in terms of cos. The angle in the numerator is 2x. The angle in the denominator is x. Can we simplify the term in the numerator? Very well. You very well know from compound angles that cos 2x can be written as 2 cos square x minus 1. What happens in the process is you get the same angle in the denominator and same trigonometric function as in the denominator. So let us proceed to write that as 2 cos square x minus 1. So same way cos 2 alpha will become 2 cos square alpha minus 1. But there is a minus outside. So we write minus 2 cos square alpha plus 1. Obviously the denominator will remain same. So cos x minus cos alpha dx. Now 1 and minus 1 get cancelled. So we are left with what? We are left with 2 common to the numerator. So let me write that 2. Now I'll put an integral. Now cos square x minus cos square alpha is of the form a square minus b square. So let us write it as cos x minus cos alpha into cos x plus cos alpha, obviously upon cos x minus cos alpha dx. What do we see? There is a cos x minus cos alpha in the numerator, cos x minus cos alpha in the denominator. They cancel out. So what are we left with? We are left with integral of cos x plus cos alpha and a 2 outside. So let me write that as 2 times integral of cos x dx. Is that okay? And integral cos alpha. Alpha is a constant, so we take cos alpha outside and we get integral dx. Now students, integral cos x is known to me. It is sin x. So 2 brackets, we have sin x plus x cos alpha plus c. X is because integral dx is x. And we cannot simplify this any further. So this becomes a final answer. And that's all we have in this module. Thank you very much.